Hey everyone, and welcome! Today we're diving into something that's absolutely fundamental for any serious Java programmer: packages. Seriously, this is the concept that separates a messy folder of code from a large-scale professional application. If you're looking to build bigger and better software, you've got to know this stuff. So, let's get right into it.
You know the feeling, right? We've all been there. You start a new project, everything's neat and tidy. But then you start adding features, and suddenly you've got dozens, maybe even hundreds of files. It stops feeling like an organized project and starts feeling more like, well, a junk drawer. So how do we get out of this mess?
So, first up, let's talk about the problem. And it's a funny one because it's a problem that comes from success. This isn't about writing bad code, it's about what happens when your project gets so big that even really good code starts to feel totally chaotic and impossible to manage.
Just try to picture it. You open up your project folder, and there are 300 different Java files just sitting there. You've got user.java, product.java, databaseconnection.java, paymentprocessor.java, all mashed together. I mean, finding the one file you need to fix a bug would be an absolute nightmare. This is pretty much the definition of code chaos, and it makes your project almost impossible to maintain.
And believe me, it gets even worse. What happens if two different teams on your project both need a simple helper class, and they both name it utils.java? Without some way to keep them separate, you've got a naming collision. How is the compiler supposed to know which utils you're talking about? The short answer is, it can't, and your program will break. So, the bottom line is, we need a way to give every class a unique identity.
So what's Java's big solution to all this chaos? Well, it's a really elegant and super powerful idea called packages. You can just think of it as Java's built-in industrial-strength filing system, designed specifically to keep your code organized. Let's see how it actually works.
Okay, at its heart, a Java package is what's called a namespace. Now that might sound a little technical, but all it really means is that it's a container. It groups a bunch of related code together and gives that group a unique name, or unique context. This grouping is what organizes your code and, crucially, prevents those annoying naming conflicts we just saw.
And honestly, the best part is how simple this idea really is. If you get how folders work on your computer, putting files inside folders, and even putting folders inside other folders, then you basically already understand packages. A folder named database inside a folder named tools in Java, that just becomes the tools.database package. It really is that straightforward.
So we know what packages are, but let's talk about why they are so incredibly important. Let's break down the three main reasons that make them a total game changer for any kind of modern software development.
Okay, so it really boils down to these three big things. First, they give you amazing code organization, which makes your project much more modular and easier to understand. Second, they manage your namespace, which stops those name collisions dead in their tracks. And third, they offer access control, which is a way of protecting your code by deciding what's public and what should stay private.
Let's really zoom in on that second benefit, namespace management, because it's a big one. Remember that problem with having two different utils.java files? Well, this is the fix. By giving every single class a specific address, packages get rid of any and all ambiguity. This is where packages are just genius. And check this out. It's a perfect example. You could have two different classes, both named Rectangle. But because one lives in the graphics package and the other lives in the Java AWT package, their fully qualified names are totally unique. Graphics.rectangle is a completely different thing from Java AWT.rectangle. The package name basically acts like a last name for your class. It's like having two friends named John, but one is John Smith and the other is John Doe. No confusion.
And that last big win here is all about access protection. You can think of this like putting a staff-only sign on certain parts of your code. You can make a class public so everyone can use it, or you can keep it private so only other classes in the same package can see it. And this is super important for building stable, reliable software, because it stops other people from depending on your internal helper code that you might need to change later on.
All right, the theory is great, but how do we actually do this? Let's get practical and look at the nuts and bolts. You're going to love how simple this is. It's really just two key steps.
Yep, that's really it. First, you declare what package your class belongs to. Then you import any classes from other packages that you want to use. Let's see exactly what that looks like in the code.
First things first, you have to declare the package. And I mean the very first line in your .java file. Nothing can come before it. This line, package com.mycompany.tools, is basically telling the compiler, hey, this calculator class I'm writing, It belongs in the Tools package, which is inside the My Company package. You're putting a label on the file before you stick it in the filing cabinet.
Okay, so now for step 2, importing. In a different file, let's say your main.java file, where you actually need to use that calculator, you just add this little import statement at the top. This tells the compiler, listen, anytime I say calculator in this file, I'm talking about the one you can find in the com.mycompany.tools package. This is a huge time saver. Imagine typing com.mycompany.tools.calculator every single time. No thanks.
Now, when you import, you've got a couple of choices. You can import a single specific class like we just saw, or you can use the asterisk or wildcard to import all of the public classes from a package at once. But here's a super important thing to remember. The wildcard only grabs classes directly inside that package. It does not import from any subpackages.
Okay, let's zoom out for a second. We've seen how packages work in our own projects, but let's look at how they're used across the entire Java world. This is literally how millions of developers all over the globe share code without constantly stepping on each other's toes.
So you might be wondering, what stops some programmer at Google and another programmer at Microsoft from accidentally creating packages with the exact same name? Well, it's a simple convention. The standard practice is to take your company's internet domain and reverse it. Since domain names are guaranteed to be unique, reversing it makes your package name globally unique too. It's such a simple idea, but it's absolutely brilliant for solving a massive potential problem.
And hey, if you want to see a masterclass on how to organize code with packages, you don't have to look far. The Java language itself is the perfect example. The entire standard library, all those built-in tools you use every day without even thinking about it, is meticulously organized into a clear hierarchy of packages.
And here's the really cool part. You've been using packages from day one, probably without even realizing it. The java.lang package has fundamental stuff like the string class, and it's so important that Java just imports it for you automatically. That array list you love so much, it comes from java.util. Reading and writing files, that's java.io. This structure is what makes a massive library with thousands of classes totally manageable and easy to use. So, to wrap things up, we have seen how packages are the key to bringing order to our classes. They are the absolute foundation for organization, for modularity, and for scalability in Java. But that brings up one last question. In really massive, complex systems, is there something that organizes the packages themselves? The answer is yes, they're called modules. But, well, that's a whole other story for another time.